Well, howdy there, Internet students. It's Mr. Hermanson again. We're going to go over some of those frequently missed questions in Practice 11.3. The first one we should probably talk about is finding the surface area of the cone right here. Now remember that surface area consists of the lateral area, which is the sides plus the base. There's one base. And what we found out about cones is that the lateral area is 1/2 the base, or the circumference, perimeter circumference, times the slant height. And then we have to add the area of the base, which is just pi r squared. Remember that. Okay, so first we're going to put it in terms of pi. Now the circumference is just the diameter, which is 4 times pi. And then the lateral height is, we actually have to calculate that here on this one. So this is a 2 here, and this is a 5. So we're going to do the square root of 2 squared plus 5 squared to get that hypotenuse, which looks like the square root of 29. So 1/2 times the circumference times the slant height. We have the square root of 29, and that's in simplest radical form. There's no perfect square factor in 29. And then we're going to add the area of the base, which is just pi r squared, which is pi times 2 squared. And then we're going to simplify this as much as we can. 1/2 times 4 is 2 pi times the square root of 29 plus 4 pi. And noticing that there's a pi in both of those, if we wanted it in simplest radical form, we could distribute that pi, and we would have 4 plus 2 times the square root of 29, put that in parentheses, times pi. That'd be simplest radical form. And then rounding that to the nearest 10th, well, you guys would know how to do that at this point. All right, the next one it looks like we had trouble with is number 13. So let's check out that one. We need to find just the lateral area. So to do that, we need the perimeter. 1/2 the perimeter times the slant height. All right, and the perimeter, it looks like each side is 10. So 10 times 6 is 60. And the slant height, I'm not sure that we're given that. But if you look at the triangle on the inside, the slant height is part of that triangle. So looking at the height of the pyramid, and then the slant height that goes with that. So the base, it said, is 5 times the square root of 3, this little triangle. And height of the pyramid is 8. So we need to use those two values to get our slant height, L. And so we're going to do 8 squared plus 5 times the square root of 3 squared. And 5 times the square root of 3 squared is 75. So we have 64 plus 75, 139, square root of 139. All right. And to the nearest whole number then, well, you guys would know how to do that. Don't worry about that. Moving on, number 15 caused some problems. So the original height of the pyramid of Khafre, located next to the Great Pyramid in Egypt, is about 471 feet. Each side of its square base is about 708. So I'm just going to draw a quick sketch of this. Pyramid, and the height of the pyramid is 471, and the square bases are 708, and we want the lateral area. Okay, so again, if I drew a line for the height like this, and then I drew over to the edge, to the middle of the edge, that would be my slant height right there. And in that triangle, we have the height is 471, and the base of that would be half of the side length, so 708 divided by 2 would be 354, and then our slant height would be the hypotenuse of that triangle. And I get the square root of 347,157. So there's your slant height. So now we're going to do the lateral area as 1/2 the perimeter, which is 708 times 4, 2,832 times the slant height, which is 347,000, square root of 347,157. It's round to the nearest foot, so there's the math you would do to get that. All right. Looks like number 27 caused some concerns, and number 28. Let's just do one of those. So if we think about 27, we have the lateral area of the cone part, which is going to be 1/2 times the circumference of that cone, which is 10 times pi. So that's the lateral area of that cone. And then we have the lateral area of the cylinder part. The lateral area of the cylinder part is the circumference times the height. So the circumference again would be 10 pi times the height of the cone, and that looks like 6. Then I have one more part to add on that, and that's just the top part, the base of that, and that's just pi r squared. And basically I just need to add all those up. It says the nearest whole number, so that's the math you would do. Now in this one, I won't do this whole one, but at 28 was a struggle also. It looks like on the rectangular prism part, there are 5 faces of that. So there's the 2 by 2 face, and there's 4 of the 4 by 2 faces. And then we have to find the lateral area of the pyramid part, which is 1/2 times the perimeter, which would be 8 times the slant height, which is not given. Here's the little triangle you would use to get that, though. You would have a base of 1 and a height of 2. So it'd be the square root of 5, it looks like. All right. Looks like number 30. So you get a cone that looks like that for number 30. And so you would have to do to get the slant height. So it's going to be 1/2 the circumference, which will be 30 pi, times the slant height. And the slant height is going to be the square root of 30 squared plus 15 squared. All right, and then number 41. So number 41, 1/2 the lateral area, which is 1/2 the circumference, and the circumference, we're not sure, but we'll just label that as C. Actually, let's do this. let's say it's 2. So 1/2 times the circumference, let's call that 2 times pi times r for now. So 1/2 times the circumference times the slant height, which is 10. That's equal to 64 times pi. We're going to divide out the pi from both sides, get rid of those. And then we have 10r is equal to 64. So r is equal to 6.4. I don't think we needed to do that. I think that that we just have 64 pi for the area of the lateral area. And if we flatten that circle out, we would have 100 pi. And so the ratio 64 pi represents the area of the lateral area of the cone compared to the area of the whole circle. And if we take that ratio and multiply that by 360, whatever that answer is, that gives us 230.4. That would be the number of degrees of this part, but they want the other, so let's just subtract that from 360. And we get 129.6. All right, hope this helps. Talk to you soon.